Hello again. So we are covering 12.6, but I will be doing it in two parts. In this video, I will cover Pascal's triangle, and then we will cover the binomial theorem in the next video. Okay, so the binomial theorem is basically binomial expansion. And binomial expansion is basically taking a binomial and raising it to a power. Okay, so maybe you remember Pascal's triangle from way back in elementary school. If not, don't worry about it. Okay, so this is 12.6, the binomial theorem, but we aren't going to quite get to the binomial theorem. Okay, so I'll call this part one, Pascal's triangle. Okay, so this is just one way to expand a binomial that's raised to a power. So before we go into Pascal's triangle, let's take a look at let's just keep a general binomial, and let's see what happens when we raise it to the second power. Okay, so that basically means a plus b times a plus b. And maybe you have this one memorized. Maybe you already memorized that it's going to be a squared plus 2ab plus b squared. Okay, so maybe you already have that memorized. Great. Okay, let's take a look at a plus b raised to the third power. So that means a plus b times a plus b times a plus b, right? Okay, well, we already know what this equals. Okay, that's just going to be a squared plus 2ab plus b squared. Okay, so now we have to distribute that. Okay, um, okay, so a squared, I'll go like this. I'm going to go this way. A times a squared, a times this, a times that, and then b times that, b times the middle, b times b squared. Okay, so a times a squared is a cubed. A times 2ab is 2a squared b. A times b squared is ab squared. Now I'm going to distribute the b, this one right over here. So I'm going to multiply all three of these terms by b. So I will get plus a squared b plus 2ab squared plus b cubed. Okay, and let's go ahead and combine like terms. I only have one a cubed, a squared b's. So I have one here and here. So that makes it 3 a squared b. And then I have this one and this one. So that's 3ab squared. And then I have that b cubed at the end. Okay, great. All right. And then if I want to do a plus b to the fourth power, then that is a plus b times a plus b times a plus b times a plus b, right? And I know this part is a squared plus 2ab plus b squared. But then so is this part, right? And then I would have to distribute this and then combine like terms. Let's do it so that we can appreciate the binomial theorem and Pascal's triangle. Okay, so doesn't matter. So I'll distribute this way this time. Okay, so I'll multiply a squared times all three of terms here. So I get a to the fourth plus 2a cubed b plus a squared b squared. Okay, now I'm going to distribute 2ab to these three terms. So plus 2a cubed b plus 4a squared b squared plus 2ab cubed. Okay? And now I'm going to distribute b squared to all three of these terms. Let's see if I can squeeze them all in here at the very end. So I get plus a squared b squared. And I get plus 2ab cubed. And I get plus b to the fourth. Okay, great. And let's go ahead and combine like terms. I only have one a to the fourth. Okay, so we got that one done. A cubes, I have one here, and I have one here. Okay, so we did that one and that one. Okay, let's just double check. Okay, a squared, b squared. 1 plus 4, that's 5. That's 6. So we got 1 plus 4, that's 5, plus 1. Okay. 2ab cubed and 2ab cubed, so that makes 4ab cubed. And then this last one, plus b to the fourth. Okay, so this is our final answer for that one. And then if we do a plus b to the fifth, do we really want to do a plus b to the fifth? No, not really, right? Okay, so a plus b to the fifth would just be all of this right here, right? A plus b times a plus b times a plus b times a plus b times a plus b. But we know this part is the answer right above this right here. So we'd have to distribute a plus b to these and then combine like terms. Okay, but I think that was enough work so that we can really appreciate Pascal's triangle. Okay, so maybe you remember Pascal's triangle. Let's see. Um, so it starts off like this. Okay, so it starts off with a 1 at the very top. Okay, and then 2 ones over here. So you've got this triangle of ones that you start off with. And then everything else can be derived from here. Okay, so we always start with 1 and we end with 1. And what we end up with is a pyramid of numbers. Okay, so we started off with 1 number, then we have 2 numbers, so then we'll have 3 numbers next. And the row of numbers always begins and ends with 1. So this next row is going to have 3 numbers. It starts with 1 and ends with 1. Okay, so the middle number over here turns out to be the sum of these two. Okay, the sum of these two. So that's 2. Okay, the next row is going to have 4 numbers. And again, they always start with 1 and they end with 1. So this is going to have 4 numbers. So we need 2 more in the middle here. Okay, and again, it's going to be the sum of the 2 numbers. So right here and right here. Okay, so when we add those, I get 3 and 3. Okay, the next row will have, since this one had 4 numbers, the next one will have 5. Starts with 1, ends with 1. Okay, to find out the numbers in between, you just add these, and add these. And that's how you get the 3 numbers here for 5. Okay. So that's 4, 6, and 4. Okay. The next row will have, this one had 5, so the next row will have 6 numbers. Starts with 1, ends with 1. Why don't you see if you can fill in this row? So hit the pause button and then fill it in and then come back and check. So we're going to add these two, these two, these two, and these two. And that will give me 4 in between and the 2 ones, making it 6 numbers. Okay, so it's 5, 10, 10, 5. Okay, so hopefully you got the same numbers that I did, and we can continue doing this. We would have 1, 6, 15, 20, 15, 6, and 1. Okay, so hopefully you see some symmetry here. Okay, and we can keep adding to the pyramid, adding another row, adding another row, adding another row. Okay, so what's the connection here to binomial expansion? Okay, so let's take a look at these numbers here. Okay, so over here, pay attention to these numbers here. In this row, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay, now let's go up here. Starting over here. Look at the coefficients here. 1, 2, 1. Look at the coefficients here. 1, 3, 3, 1. Look at the coefficients here. 1, 4, 6, 4, 1. Those are the numbers in Pascal's triangle. 1, 4, 6, 4, 1. So over here, if I wanted to multiply this out, I know I'm going to get 1, 5, 1, 5, 10, 10, 5, 1 for my coefficients. So 1 plus 5 plus 10 plus 10 plus 5 plus 1. So how do I get the rest? Well, if I take a look here, okay, so if I take a look up here, let's take a look at some patterns that we see here. See how we have a for our first term? Well, if you notice, in our final answer, we have a to the fourth, right? A to the fourth. And then it descends. A to the 4, 3, 2, 1, a to the 0. And then for b, we have b to the 4th, the second term, but it starts over here on the end. B to the 4, 3, 2, 1, b to the 0. Okay, so over here, when I fill this in, then I know I'm going to start with this first term to the 5th power, a to the 5th, 4, 3, 2, 1, 0. And then I'm going to do b to the 5th, starting on this end, b to the 5th, 4th, 3rd, 2nd, 1, and none. And this is going to be our answer. Okay, so this is a final answer for that. We didn't really have to do much. And over here, if I wanted to do a plus b to the 6th power, then I can use this row for my coefficients. Okay, so it's going to be, here, I better put it over here, 1 plus 6 plus 15 plus 20 plus 15 plus 6 plus 1. Okay, and I start with this first term. This first term, this here is very simple because we just have a single letter here and a single letter here. We could end up with like 2a, and we would have to do 2a to the 6th, 2a to the 5th, 2a to the 4th, 2a to the 3rd, 2nd, 1st power. Okay, but this one's really simple, so it's going to be a to the 6th, 5, 4, 3, 2, and 1. Okay, and same thing here. The second term is just a b, but we could easily get 3b. Okay, so it's going to be b to the 6th, b to the 5th, b to the 4th, b to the 3rd, b to the 2nd, b to the 1st, and b to the 0. Okay, and you can always, there are some checks you can do at the very end to make sure that you got all of your exponents correct, because see, this is a 6th power. Your exponents should always add up to 6. 6 plus 0 is 6. 5 plus 1, 6. 4 and 2, 6. 3 and 3, 6. 2 and 4, 6. 1 and 5, 6. And there's your 6. Okay, so again, if we wanted to find a plus b to the 7th, we could do another row for 7. We can do this same process for subtraction, binomial. Okay, so if I had a minus b to the 6th, oh, well, that didn't come out right. Okay, so a minus b to the 6th. If I have that, it's the exact same process. The only thing that changes is that your signs will alternate: positive, negative, positive, negative, positive, negative, positive. Okay, so so here you would still use the same coefficients for power of 6. Okay, so that's right here, and you can tell which row because it starts off with your power: power 6, power 5, power 4, power 3, power 2. Okay, so we would be using positive 1 minus 6, positive 15 minus 20, positive 15, negative 6, and positive 1. Okay, so that's the only thing that's different when you have subtraction. Okay, but everything else is the same. A to the 6, 5, 4, 3, 2, and 1. And then b starts over here, b to the 6, 5, 4, 3, 2, and 1. Okay, all right, and let's go ahead and take a look at a binomial that isn't as straightforward as a and b. Let's take a look at this one. Let's do 2 minus 3x to the 5th power. 2 minus 3x to the 5th power. Okay, so that means we are going to be using this row for our coefficients, and we're going to have alternating signs. Okay, so we're going to have 1, let's bring that back, 1, negative 5, positive 10, negative 10, positive 5, negative 1. Positive, negative, positive, negative, positive, negative. And we're going to have, so it's going to be our first term to the 5th power, right? So our first term is 2. So 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st. And then over here, we're going to just take the 3x. We already accounted for the negative, so we'll just take the 3x. 3x to the 5th. So you can see here, if we plugged in negative 3x, we would have gotten negative. So that's why the signs alternate. Okay, 3x to the 5th, 3x to the 4th, 3x to the 3rd, 3x squared, and 3x. Okay, and then you would need to make sure that you multiply all of the numbers together. Okay, so like here, you would need to make sure 2 to the 4th is 16, 16 times 5, and then 5 times 3. So you would have to multiply all of these out, okay? So when you do that, you get 32 minus 240x plus 720x squared minus 1080 x cubed plus 810 x to the fourth minus 243 x to the fifth. Okay. All right. So that is Pascal's triangle. We are going to look at another way to use to expand binomials using the binomial theorem. And it's quicker if you have a calculator, so make sure you have a scientific calculator ready. You do have a scientific calculator on your phone. If you click on your calculator and then you turn it sideways, we're going to be looking for. Make sure you have the factorial button. Okay, so for the next lesson. So the factorial button on your calculator looks like this. Okay. All right. And let's see, what else will you need? Okay. All right. And then I'll show you the formulas for the binomial theorem and expansion and finding a particular term in a binomial expansion. Okay. All right. So that's about it. This is Pascal's triangle. This is one way to expand binomials. It's faster than doing it all by hand, right? But I would say binomial theorem is probably a little bit faster, unless you have these small exponents. Okay, then this is relatively quick too. Okay, all right. If you have any questions on this, make sure you message me.